computers are great at playing chess. But despite repeated attempts, we have been unable to design a robot butler that can do a simple load of laundry.
I'm Michael Tamblyn, CEO of Rakuten Kobo. This is Kobo in Conversation. My guest today is Janelle Shane. She's the writer and chief experimenter behind the blog AI Weirdness, which is where leading-edge machine learning tips over to crash and burn in hilarious ways. What brings her to this show is that she is the author of the book, You Look Like a Thing and I Love You, How Artificial Intelligence Works and Why It's Making the World a Weirder Place, which is as funny as it is illuminating on questions of why I do not yet have the robot butler that was promised in science fiction in my childhood, or even why you shouldn't trust AI to bake you a cake. Janelle Shane, welcome to Kobo.
Hey, thanks so much for having me here.
You are an optics research scientist by day. How did you branch out into making AI do improbable things?
Well, my interest in AI came first, actually. So that's where I started doing my research. We're in a lab that was applying evolutionary algorithms to different kinds of problems. And one of those problems turned out to be the question of how do you shape a laser pulse to break apart chemicals in specific ways to get particular products that you want. And so I jumped right in, started applying AI to that problem, and then after a while realized that once we understood it well enough to apply the AI, we realized we didn't need AI anymore. The effect in our case was just as simple as turning the laser power up and down. So that turned out to be an illustrative sort of example in how a lot of AI research goes and how AI can be a last resort to a lot of problems. It's applied right now in ways that it doesn't necessarily have to be. But I always had this interest in AI because it is such an interesting, you could almost say a phenomenon. You set up a computer program in a particular way and it does weird stuff kind of predictably. And weird stuff that humans wouldn't think of doing. So that I always had that interest in mind. And then when I saw somebody post a experiment with a text generating AI program, and they were generating cookbook recipes, and they were the most hilarious things I'd ever seen. So it had no idea which ingredients it should use. It was misspelling most of the ingredients or making up things that didn't even exist. I think I completely lost it at the shredded bourbon. And it was just, once I finished reading all of the ones, and the guy's name was Tom Brewer. And once I read all the recipes that he posted, I wanted there to be more in the world. And that's where I learned how to start generating these and doing these experiments myself.
So what was the first experiment that you did yourself that you then unleashed upon the world?
It was cookbook recipes because I had seen an example of how to do that. So the Silicon Gourmet is the name of that first post on neural nets. And up till that time, that blog had been my grad school optics, nanofabrication blog. And I'm like, oh, it's kind of sciencey. I already have this blog started, so I'll throw some neural net experiments on there too, just so I can show them to people or have somewhere to point people toward. And turns out other people thought these were kind of funny too.
The title of the book comes from an experiment where you trained an AI to create pickup lines. So just to give people a sense of how these things come together, how do you teach an algorithm to do that?
Yeah, so what I needed to do was come up with examples for it to copy, because these AI programs learn by example. And so you give it a bunch of things that are in the set of kinds of text you want to learn to generate, and it will learn to predict, okay, given the first couple of letters in one of these things, of like a line of a recipe or a pickup line, it will learn to, by via trial and error to predict what comes next in that line. And so I needed to first collect a bunch of examples of pickup lines. And actually, that step nearly killed me because I don't know if you've read like lists of pickup lines on the internet lately, but they're terrible. Like, if they're not offensive, they're cheesy, or just like don't work, or, they're bad. And so it was definitely at that point that I almost gave up. But the next step then is to, once I have this list, and I think I only managed to get like a few dozen of these things before I just gave up in disgust. But once you have your list, you have to give it to this program. In this particular case, it was learning from scratch. It had never seen English before. All of these letters that it's trying to predict in what order they should come, they're all represented by numbers. So if you looked under the hood, it would be predicting like what strings of numbers come after another. Like, it has to learn completely from scratch. And like you can see it generating output as it's checking itself, and its first few generations are just garbage. It's a bunch of random letters and punctuations, and it starts to learn to use spaces, but it overuses them. And then you have like, it goes through a phase where everything is a space and there's no text, and then it'll pick a favorite word that you'll see. Like with the recipes, like the first word that I saw it learn to produce was the word teaspoons, because that comes up a lot in recipes, but it couldn't spell it quite right. So you would get like, it'd be like teaspoon, poo poo, So it's kind of fun to watch it figure that out. And then it starts figuring out more and more sequences and stuff that it can put together. And eventually, you just have to stop the training and say, well, it's gotten about as far as it's going to get. So either it's not making any more progress, or it has memorized your input data set and is just giving you your data back word for word. It's like, well, this is what you wanted, right? Like, yes, but okay, yeah, technically that is a perfect answer to the request to generate something like this, is to generate exactly this again. So usually at some point you just have to stop learning and say, well, okay, that's all it's going to do. Like, it definitely does not progress to the, now I'm going to take over the world. No, got to shut it down. That's no, alas. It just gets more and more boring.
It's not even figuring out where the switch is. Yeah. So what is it about what the algorithm's doing that makes it kind of capable of being unintentionally hilarious? It's making things that are kind of shaped like pickup lines, but not very good at picking anyone up.
Yeah, well, puns are really tough, because they rely on a lot of like context, and these algorithms tend to be pretty bad at broad context and like making connections. So the puns always fall completely flat. And then if you've got a smallish algorithm that's just trying to learn English from scratch from a few examples, there's a lot about English that it doesn't quite get as a reliable pattern it can reproduce. So you'll get weird grammar of sentences, especially the one I was working on with the pickup lines. Like, it's got a limited memory, so it won't remember what it said, and it won't remember how long sometimes if it's really short, it won't remember how long the sentence is that it's working on. And you get these doozies of a sentence that's like this run on, repeated. It's almost like a chant sort of mantra thing. Yeah, all sorts of weird things it just cannot get that humans would.
So you end up with, just so that I could provide some examples, pickup lines that sound like this. You must be a Tringle because you're the only thing here. And, hey, baby, you're to be a key because I can bear your toot. And, are you a candle? 'Cause you're so hot of the looks of you. It's just, I'm swept away. I don't know. I don't know why anyone else isn't. There's a real risk in examples like this of just writing the whole field off and saying, see, AI is dumb. It was all just a lot of hype. But one of the things I really like about the experiments in You Look Like a Thing and I Love You, is that you managed to show two things simultaneously. First, the output itself, which is funny, but also you reveal that it's kind of amazing that they can even do as much as they can do.
Mhm.
If you can only remember a few words or letters into the past, it's kind of amazing that you can come up with something that sounds almost human. And
Mhm.
I was wondering if you were trying for both of those, like both to show the capability and that sometimes it just runs at a wall and bashes into it.
Yeah, I really was trying to show both sides because it's interesting with these algorithms is that we kind of don't have a good intuition about what's easy versus hard for them versus easy and hard for us. We almost have reverse sorts of capabilities. And so you get, for example, a lot of people have this intuition that playing chess is really hard and really high prestige. You must be very smart if you're good at chess. And whereas we tend to hold things like doing laundry or housework as sort of low prestige sort of things and say, well, that must be an easy problem and chess must be the hard one. But if you look at AI, it's actually the other way around. So chess is a narrow, constrained problem, and computers have beaten our chess grandmasters soundly for many years now. Like computers are great at playing chess, but despite repeated attempts, we have been unable to design a robot butler that can do a simple load of laundry. So we have this kind of skewed perspective, and I think that kind of intuition, we need better intuition to serve us well when we're trying to think of whether to trust an AI that's going to be, for example, suggesting who we're supposed to hire for a job. Like, oh, AI must be great at figuring that out. Well, is this really in line with AI's strengths?
The theme that you come back to multiple times in the book is that the more narrowly you can define the problem, the more constrained you can make the space in which the AI has to work, the smarter it's going to appear.
Yeah.
When you were talking about recipes, you used machine learning to generate a carrot cake recipe. And looking at the ingredients, at least, yeah, it actually did pretty well. You could imagine all of those things as being essentially cake-like, or
Mm-hmm.
you could imagine throwing them into a bowl and getting something that, if it didn't look like cake, would at least kind of fool an untrained observer. But then, as soon as you branched out from cake to multiple different kinds of recipes, everything kind of falls apart. The wider the problem gets, the harder it is to produce something that seems reasonable.
Yeah. Yeah, exactly. And we run into this all the time. If you think of self-driving cars, the problem of can you stay on the lines and obey the road signs, that's a fairly narrowly constrained problem. And self-driving cars have been pretty good at that for a while. But when you bring in, and can you deal with all the unexpected stuff that happens on the road, like now there's a billboard with a stop sign on it, what do you do? Or there's an escaped emu, you've never seen an emu before, what do you do? And that is what self-driving cars are really struggling with right now, to try to handle these kind of get rid of these unexpected and sometimes very serious fatal glitches.
You make it clear in your book that what we call AI is really a basket of techniques, and
Yeah.
that each one can be good for a certain kind of problem and not others. And the first part of the book introduces us to these families of machine learning algorithms. We have neural networks and Markov chains, and generative adversarial networks and random forests and evolutionary algorithms. And
Mhm.
part of the challenge in a machine learning implementation is just figuring out which one to use. So I wanted to try a real world example with you. So let's say I wanted to teach an algorithm to write new reviews for this podcast so that it looked like I had millions of raving fans, and that there were like just thousands of reviews, all of which, extolling, your virtues as an interviewee and my virtues as an interviewer. What would be the tool that you would first reach for if you were going to try to generate my army of podcast reviewers?
Oh, now that's an interesting question. It depends whether you want to generate completely new reviews or whether you want to change all your existing reviews to be more positive.
Oh, I didn't even know that was an option.
Yeah.
Let's assume first that I think first we need just like a lot of reviews. So we need from scratch just thousands of raving fans. Mm-hmm. And then we probably have some reviews in there that, maybe aren't as great as they should be. Almost certainly my fault and not the fault of the guest. So then we probably have to change those as well. Yes.
Yeah, so probably a text generating recurrent neural network similar to the one that I trained to do the pickup lines might be what you want to go with. If you want these people to sound like they are not computers, you probably want to start with a bigger one than the one I use. So they've got some big ones right now that are trained on a lot of internet text, and including like there's a lot of reviews on the internet. And so if the text you give it to complete to predict what comes next is 5 handcrafted glowing reviews of your podcast, mentioning you and the podcast by name. And then you say, okay, now predict what comes next after these 5 glowing reviews. We've got modern algorithms that can figure out what a review generally looks like and the things it should mention, and kind of like, okay, here's the pattern. We're saying nice review type things using these kinds of keywords. And that will generate a lot of reviews. But the problem with something trained on the internet, of course, is that it's not entirely reliable. You would want to read every one of those reviews by yourself. You're on your own and really pay attention to what they're saying, because they'll maybe drift off topic and say, oh yes, and you're co-starring with Janelle Monáe and doing this podcast or something, and you're like, no, that's incorrect. So it will generate incorrect things. And it can also like maybe say things that you would not like your fans to say, whether it's not, it drifts from being complimentary or brings in stuff you're like, oh no, I'm going to content moderate that right out. That's not a good thing to say on the internet. So yeah, some progress would be, definitely some human editing would be required.
And this gets to a challenge that you describe in the book, one of the many, which is training data matters a lot, and the kind of information that you're using to train your algorithm can result in some very unintended consequences, especially when your training set is the internet. Internet has a lot of things on it that are not necessarily things that I want to have in my reviews of the podcast. But there's a lot of it out there, and it can do a really good job of convincing an algorithm that that's perfectly reasonable speech. Yeah, this is indeed a problem. We're at the situation right now where if you want the highest degree of coherence and like believable English, you have to go with one of these giant models. And right now, mainly the training data that you can get that's big enough for it to pick all of this English language structure up is the internet. And so then you're stuck with the internet as your training data. That is a real problem in modern text generation, actually, that we're really having to reckon with. And they haven't figured out how to provide the subsets that's just the nice internet or the non-racist internet. So that's where problems arise.
Yeah, this is a problem. It would be nice, and I maybe would expect to see the field getting better at training algorithms with smaller, more curated data sets, and maybe we can improve things that way.
The second part of the book talks about some of what we've just been describing, things that make AI not work as intended. And one of the things that you make clear over the course of it is that machine learning is like the story of the monkey's paw. If you say, make me a ham sandwich, there is a very real chance it will try to turn you into a ham sandwich. How much of AI use or misuse is about defining the problem correctly that you're trying to solve?
Oh man, it's all about trying to define the problem correctly. That is the biggest thing. You have to understand your problem so well and all the possible hacks and shortcuts and misinterpretations and even collecting the training data for training a text generating algorithm. Like you're giving the algorithm the task, copy this data, and what you're telling it to copy really, really matters. And we get into like, how do you even, maybe you're thinking about your training data, you have to think about the problem so clearly. There's an example of, an algorithm that was trained to predict risk factors for, and I think it was risk factors for a stroke. And they found out that the risk factors were all these seemingly unrelated things, but they were all things that would bring you into the doctor's office for a checkup. So what they were not actually predicting were people who were going to have strokes. They were predicting people who were going to be treated for strokes because they had access to health care and maybe happened to have been in the office to be checked out, that kind of thing.
So that's like, chronic athlete's foot as a stroke predictor. And
yeah. Yeah, and if you don't have healthcare access, you're not going to go to the doctor to get seen for that or for the stroke. So yeah, it's tricky like that.
Until I read this book, I had no idea how often algorithms hack the simulations that they're in.
It's a problem. We tend to train a lot of algorithms in simulation, especially the ones that are supposed to be like using real world mechanical robotic arms to do something, or driving a real world bicycle or something like that, because it takes so much trial and error that it would take hundreds of thousands of years and hundreds of thousands of busted up bicycles or robot arms or whatever in order to arrive at the solution in the real world. So we make these simulations, but no simulation is perfect. Like there's all these sort of shortcuts that we have to do to make the math kind of work without having to simulate an entire universe down to the atomic level. And these shortcuts, it turns out, can be exploited by these machine learning algorithms because they don't know any better. Like their solution is in the simulation, for example, to get from point A to point B. And if they figure out that there's a way that they can hack the rounding errors in the simulation to give themselves free energy and levitate themselves and avoid friction, and they will do that because it's a perfectly good solution according to what we asked it of. What have you asked for? You've asked it to get to point B however it can in this simulation.
There is also a whole chapter on class imbalances, which, as someone educated in the humanities, I immediately thought was about rich algorithms versus poor algorithms. But it turns out that is not the case. It means something different here. Can you describe that for us?
Yeah, so this is again another machine learning hack these algorithms tend to do, which is if you give it the problem of, let's say you've got a million customers, you want to predict which ones are going to leave in any time period. Well, in any given time period, maybe 99% of your customers don't really leave. And so your algorithm can figure out pretty quickly that it can get nearly 100% accuracy for free by predicting none of your customers ever leave. And that's what we call class imbalance.
Anyone who has spent time near AI research or the output of it knows that bias is a problem, that the data sets that you use to train an algorithm can have unintended consequences. And you brought up the example of reviews of Mexican restaurants, and I was wondering if you could unpack that for me a little bit.
Yeah, this is a really interesting research project someone did with looking at how different restaurants were being rated in online reviews and discovering that if you went through and used an algorithm to figure out whether a given review was positive or negative, the algorithm would tend to rate all the reviews of Mexican restaurants as negative reviews, even though when you, as a human, you go back and look at the data, you're like, actually, no, they said it was great. Why is this coming out negative? And so they dug into this a little further and learned that when the algorithm had figured out how to tell the difference between positive and negative text, sentiment and text, it had learned that on the internet. And on the internet, a lot of people are using the word Mexican in sort of pejorative or just in negative news coverage, because the internet is written not by, is overrepresented by certain people. So
we could just say it's full of racists. It's okay.
Yeah, okay.
The internet's full of racists.
And so the algorithm learned that Mexican was an indication of low positivity in a given bit of text, and said, oh, this must have been a negative review.
One of the things that you described that I thought was interesting is that one of the best ways to detect bias in algorithms is to have people working on the algorithms who are of diverse backgrounds. How does that help?
Well, first of all, even if it didn't help solve this particular problem, it'd still be the right thing to do. But One of the ways that it helps is that you have people who, because of their lived experience, are ready to notice these problems, to be aware of these problems, and hopefully be able to catch them before they go too far in the development process. Of course, the other piece is not just people who are working on the engineering implementation level, but also have people in positions of power, so that when the engineers say, hey, we have a problematic algorithm, yes, there's high engagement, but it's not promoting good posts. Like, these are terrible, divisive, horrible, racist posts. We should moderate those out. And you want the people in the position of power to say, yes, we should moderate those out. We do not want to post them, as opposed to someone who says, nah, why does it matter? We're getting good engagement.
And that seems to be coming up and biting researchers over and over again. We seem to see it fairly often with facial recognition. A particular algorithm may be really, really good at classifying faces as long as they are white faces. And then other than that, not nearly as accurate.
Yeah.
So from a purely technical question, is that because training sets are too biased towards white faces? Is that because the way the algorithms themselves have been trained or configured? What creates that negative outcome that we look at and go, why can't this algorithm figure this out correctly?
Right. Well, you're exactly right that the training data is definitely part of it. So if you've got training data that represents white faces, then the algorithm is just going to be better at that. Another problem that doesn't come up as often, is also important, is benchmarks. So a lot of the benchmarks that you're testing your algorithm against, trying to figure out if it's better than other algorithms that have been published before, is to say, okay, let's use a standard data set and test ours on that data set and see how it does. And a lot of these standard benchmark comparison problems are super heavily skewed toward white faces, for example. So that comes in as well as a problem. And then also you have people who are giving the go, no go, shall we roll this out, shall we not, who don't say, okay, before we do anything, let's check and see if there's bias there. Oh, if there is, we will not roll it out. Instead, you have people who say, we'll fix it later, or who didn't test it because they didn't want to know. But then when people bring it up, as famously happened with a really influential paper showing, hey, a couple of years ago, these algorithms have bias. And now it's been a few years. There's been time. These algorithms still have bias. And it's kind of pointing back to, similar to the idea of providing some kind of goal for a machine learning algorithm to optimize. And if you choose that goal incorrectly, it will solve the problem in a way you don't want. We are essentially, some of these companies are acting a lot like AIs with faulty reward functions, where they're getting rewarded for one thing which is not actually the thing we as a society really should reward them for. And they don't get penalized enough when they have these really serious problems with them.
Are you saying that there may be negative externalities that come from rewarding a company entirely on engagement and advertising views?
It is just possible.
There's kind of a transition in the way that you've been out there in the world as a person talking about AI. Like AI weirdness kind of grew out of these experiments you had, but it's also sort of flipped you over to becoming kind of a public educator on what AI is and what it can do. And I'm wondering if there was a conscious switch that flipped for you on that, or if you've just sort of evolved into it along with the ice cream flavors and everything else.
It was definitely not a conscious thing. I mean, it was a, science communication blog from the get-go, but I was not really expecting anybody to take my ideas seriously. I mean, I was posting about, funny AI generated recipes and paint colors. Like, clearly this is a joke blog. But then people would contact me for questions about, hey, there's a new paper that just came out, and okay, I guess I got to go read this paper. Or they would ask me for comments on high profile AI mishaps that happened in the news. And so people had these questions. They saw me as somebody who might know something about the answers. And so that was part of it. People would also, like, I saw this pervasive, people would read my blog and say, wait, how is this AI? Because AI is really smart, isn't it? So how is this the same thing that's like having all these commercial successes and people tell us is about to take over the world? And I would say, oh, well, there's maybe some interesting things to be said about taking AIs out of their comfort zone and really showcasing where the cracks are, where they're not so good, where they really differ from how humans would approach the same problem.
Is one of the challenges in talking about this field that you can sort of skate along the surface with recipes and the names of different kinds of paint, but if you want to talk about what works and doesn't work, you quickly dive below into this ocean of technical detail.
Yeah, there is a lot of different ways to get deep into different aspects of machine learning. I studied some machine learning algorithms, but I didn't really get deep into any of it to use. It's a weird kind of position to be in where I'm reading these works done by the people who, for example, have been doing really groundbreaking work in bias. There's been a lot of really great research coming out of there, and I'm kind of reading it, understanding it, and trying to point people toward it or summarize it and say, hey, in a nutshell, in a tweet, here's this cool thing someone found or noticed. But yeah, there's so much technical depth and so much to understand, and I'm only so many hours in a day.
One thing that becomes clear as you go through the book is that AI brains just aren't like human brains, but you do touch on some places where they have functions that are similar. You mentioned even examples where you can kind of perform brain surgery on a neural network. Where are the places where there is that little bit of mapping between what some of the algorithms are doing and how our brain itself works?
Yeah, there are some. And in fact, the origins of this whole class of, like, one of the most popular class of AI machine learning algorithms is called artificial neural networks. And these were designed as kind of simulations on how networks of interconnected neurons, like in the brain, might learn to solve problems. And so those have been around for decades and decades. And people have said, oh yeah, in these artificial virtual neurons, we can connect them to do basic calculations. That brain surgery thing that you mentioned, yeah, if you cut out particular neurons from these interconnected neural networks, you will find that it will change the way that the whole network behaves, or you can find neurons that are largely responsible for one task, like, maybe representing couches or something, or placing couches in a generated landscape or something. Then you knock that out and suddenly the couches are gone. Things like, there are some analogs with people. One of the interesting kind of close analogs with how is in the visual system. So there is a recent paper kind of looking at, we've known for a while that when mice and people kind of create mental maps of a environment when moving through, we tend to have neurons in a kind of grid that are arranged in a sort of grid that are responding together to the different parts of the landscape. And we have seen in the artificial neural networks, we also get these sort of virtual, very similar sort of grid structures popping up. So yeah, it's been really interesting.
And so you're seeing the neural network starting to create, effectively structures that are quite similar to how the brain tries to process similar problems.
Yeah, at a much simpler level.
One of the topics that comes up over and over in the different kinds of neural networks that you describe is the issue of memory, that algorithms aren't great at holding things in memory. And so when you're working with a recurrent neural network that's trying to generate pickup lines, it's only holding a few characters that it's already generated kind of in its mind as it's trying to predict the next ones. And that was shocking to me because I personally can't imagine what that would be like. But it also seemed like that was the biggest constraint or one of the big constraints to machine learning getting better. And so I was wondering if that's something that has a chance to sort of change or break through over time, and therefore see another kind of quantum leap in how good these algorithms are at kind of simulating and predicting human speech.
Yeah, and that is one of the things that has, I think, probably the aspect of machine learning that has changed the most, even since I put together the book, is that people have managed to find ways to give these text-generating neural networks more memory. So the modern ones that we're working with now can keep maybe a couple thousand characters in memory at once. And so you can get callbacks to things that happened paragraphs ago. It can sort of keep track of the parts of a recipe and sometimes not even use vanilla 5 times in the same recipe. So that is one thing. And there's been some clever programming to figure out how to build in like multiple levels of looking at large scale versus zooming in on small, like sentence level or word level details. There's been some smart use of that. And there's also been just a heck of a lot of computing power chucked at these algorithms. So when OpenAI released their GPT-3 algorithm, they had trained it on, as they put it, most of the internet. And it has way more memory and it's huge. And I forget how much the training cost, but I think I want to say it was in the tens, if not hundreds of thousands of dollars in computing time that it took to train this algorithm. So I had been training the pickup line generator and some of these early recipe generators. I've been training that on my own laptop, like a 2010 MacBook. So there's also, that makes a huge difference.
Yeah, you were teaching an earthworm how to make pickup lines, and now you might be able to get something with a few more, slightly more brain capacity.
Yeah, we may be up to Bumblebee, possibly.
Does that mean, though, that one of the things that's been such a characteristic of the algorithms that you've been using is that their limitations are kind of what create the hilarity. The fact that it can't remember what the beginning of the sentence was by the end of the sentence is how you end up being a thing, and I love you.
Yeah.
Does that mean we're just going to start seeing less humor coming out of the experiments as the algorithms get better?
The humor has changed. So things that were funnier before aren't as funny now. Now, yeah, that sounds like a boring human wrote that sort of thing. Or, if you ask it to write a blog now, it will generate this really generic, like you could skim right over it, self-help or business wellness or whatever kind of thing. So it's that much better at readable boilerplate text. Like if you were falling asleep while someone was reading this to you, you might not notice that it doesn't all make sense. So yeah, I have had to change my techniques. There's some stuff that I can do now that I used to not be able to do. Interestingly, I did revisit the pickup lines with much more competent neural network. So using like the modern GPT-3. And I've been resisting this because I thought, well, if it's read all of the pickup lines on the lists on the internet, then surely it's got like the most common ones memorized by now, or just it's not going to be much fun. But eventually I did try it just to see. And actually, I was surprised that it was not as far along as I had expected it would be. So I think one of my favorite ones is, I'm losing my voice from all the screaming your hotness is causing me to do.
Excellent.
Or there's another one, you look like Jesus if he were a butler in a Russian mansion. You know,
I would swipe right just on the basis of that alone. You wrote a piece in the New York Times in 2019 about the feral scooters of Central Park.
yep.
And I'm wondering if you can tell us a little bit about that. It is a story that everyone should go out and read. But for those of our listeners who are trapped under something heavy and can't press pause, can you talk about it a bit?
Sure. So this is a really fun experiment. I was supposed to write what was, this sort of op-ed from the future. This was what this series was called. And I wanted to write it about machine learning algorithms that are kind of similar to what we have today, because there are so many stories about AI that's like almost all of the stories about AI are about AIs that are light years beyond what today's technology can do. And so I remembered reading a tweet by, actually is a Georgia Tech AI professor who was grumbling about the scooters that somebody had left under his window, and they were just beeping at each other. And it's, this is some kind of like, I think mating call or something. Can they just leave? And so that got me thinking, like, what if these scooters had a sort of artificial biology to them? Like they were rewarded for getting themselves back to their charging stations, and they were rewarded for moving themselves to a place where they could maybe collect a rider and do a fare. And so I kind of figured out how that would work. But the scooters, of course, they have their flaws too, and as they're not rewarded for exactly the things that people would want. So the two scooters would tend to misbehave because they're acting in their own interests. And I had a lot of fun putting that together. And you have you have warring scooter gangs that are like protecting their turf, and we've got the 3 beeps versus the beep boops, and yeah, I had fun with that.
Yeah, it was pretty good. As booksellers, we of course are interested in whether an AI will ever be able to write a novel. Mm-hmm. And certainly from the technologies that you describe, that question of long memory, that difficulty of holding things over a long period of time in memory seems like the big challenge. So how hard is AI writing a novel as a problem to solve? And is that something we see in our lifetimes?
Yeah, I think the problem is writing a novel that anybody would be interested in reading. Because we can generate novel
That's
length
enough of a
text.
problem for humans.
I know. We can generate novel length text, but the problem is if we've trained it on existing novels, it's going to try to write like the average novel. And so even if it manages to be coherent over the paragraph, over a long period of time, it's going to be sort of boring, generic boilerplate stuff. And right now, we also still don't really have the memory. If you're using one of these big algorithms that can keep about 2,000 characters in memory at any one time, even within that length of time, it tends to drift a bit. And so it'll kind of, it's like being in a dream or something. It'll forget where it is or what it has done or what's in the box, and new characters will show up. Like it has a tendency to like start drifting into fan fiction if it's doing fiction. And then, like, all of a sudden, Frodo shows up. And you're like, oh, no.
Two last questions for you. First, you asked an algorithm for a recipe and it came up with horseradish brownies. Did you try to make them?
I did. And I would not have even attempted it had somebody not messaged me and said that they tried the horseradish brownies and they were delicious. And I had questions. And, oh, no, you don't put in straight horseradish. You put in horseradish, dressing, the cream, horseradish cream stuff, and that is what makes it okay. I'm like, oh, okay, I'll try it. And I knew I was in for trouble when, like, I opened the oven, my eyes just started watering. Like they were terrible. Like, distressingly terrible. Like I had no idea how much I hated horseradish until after these brownies. And I learned that there are some people who feel the same way I do. There are some people, on the other hand, like this person who recommended I try the recipe, who absolutely love horseradish. And so I've had a couple of the people I've served it to keep asking, oh, when are you going to make those delicious brownies again? And it takes a lot to induce me to do that again. Yeah.
And then before we go, I found one good AI joke. Do you want to hear it?
Sure.
Human. What do we want? Computer. Natural language processing. Human. When do we want it? Computer. When do we want what?
Yep. Okay, that's good.
That's it. That's all I've got.
No.
Janelle Shane, thank you so much for joining us.
Well, thank you. It's been a pleasure.
I have been speaking with Janelle Shane, author of You Look Like a Thing and I Love You, How Artificial Intelligence Works and Why It's Making the World a Weirder Place. You can find it at Kobo and Conversation's home on the web, kobo.com/conversation. There's a link in the show notes too. Kobo and Conversation is produced by Nathan Maharaj and hosted by me, Michael Tamblin, and we're both relieved that it sounds like we're not going to be replaced by an AI anytime soon, though it might be fun to try. Thank you for listening.